All right. Welcome everyone to today's session. Today's session is on analyzing your research data, quantitative analysis. So we'll be focusing more on quantitative analysis for today. Tomorrow will be qualitative analysis. So we already understood from past lectures that quantitative data has to do with numeric data that comes in numeric form. So what should we know about quantitative data analysis? For this lecture, we'll find out the types of quantitative data screening and validation, data analysis procedures and modeling, and how to select appropriate data analysis techniques, data presentation and visualization, as well as several quantitative data analysis tools. All right, so what are the types of quantitative data? We have the cross-sectional data. The cross-sectional data is a set of observation on the values a variable takes at a point in time over different units. So it's data that is collected at the same point in time, okay? So let's say you're doing a survey and you just want to see, okay, we have an example here of country, the cases of COVID, the deaths, the recovery. So let's say this was taken at a particular point in time. The World Health Organization just want to know what the cases of COVID is like at this point in time in Angola, what the death rate is like, what the recovery is like. So once it's been taken, say once, okay, over different units or different variables. Last time we explained what variables are and what scales are. So variables are the concepts you want to measure, while scales are those questions or those measures that you're using, those little things, those items you're using to measure the variable itself. So for this study, our variable here are 3: cases of COVID, deaths, and recovery. Our observations are the countries, say Angola, Botswana, Komosoro, I don't know what country that is, Nigeria, and all of that. So for Angola, the observation for the cases of COVID is 6564. The observation for death is 345. That's it. So this is a cross-sectional data. It was just taken at a particular point in time over different units. We have the time series data. The time series data is a set of observation on the values a variable takes at different times. So time series data is it's a sequential set of data points measured typically over successive time, okay? So just to put it straight, you saw what cross-sectional data looks like. So when you have cross-sectional data that has been taken over successive times, okay? So let's say for the cases of COVID, for example, we saw it across different countries. Now, if you're looking at it, let's say for Nigeria, you want to look at the cases of COVID at different time, like at a successive time, maybe for a period of years or for a period of months. So in March, you take the number of COVID. In April, you do the same. In May, you do the same for several variables. But this time around, the time is coming in here. It's not taken at a point in time. It's taken over successive times, okay? Then that is the time series data. How about panel data? So panel data is a combination of cross-sectional and time series data. So you can see the example here. You have Botswana. So this is an example of say GDP and FDI for different countries over a period of time. So we have Botswana here, and we took the GDP for Botswana as at 2010, 2011, and 2012. And we did the same for the FDI for, that's the foreign direct investment for Botswana as at 2010, 2011, and 2012. So we can see the time series aspect here, and we can see the cross-sectional aspect here as well for a particular observation, Botswana. So when you have the same for, you can see that it's for 3 different observations. The observations are Botswana, Niger, and Nigeria. But the year, the time series aspect comes in here with the introduction of the year. So I'm looking at it across 3 years, and then these are the variables that are being examined. So panel data is more or less like a cross-sectional data that has been taken over a period of time. So that is the panel data. So for those who will be working with secondary data, if you know that your data look like this, then you just need to understand where your data fall, or what kind of data or what kind of quantitative data you have. It's good to understand that. If you're just taking a survey that has been done just once, then that's a cross-sectional data. If you're taking data that has to do with, let's say like some kind of monthly reports for a particular company, okay, the monthly reports for let's say 10 across 10 years or something, then you know that that is time series data. Then when you have it mixed together, like it's cross-sectional and at the same time it has a time series feature to it, then that is panel data. So for time series data, this is the modeling, but I think this is a regression modeling for this. For time series data, the model looks like this. The y is a dependent variable, but you can see y for t equals to alpha plus beta. I don't know if this is very technical right now. So we have the y, which is the dependent variable, the alpha, which is a constant, plus the coefficient of x. This b, this thing that looks like b here, or this beta sign, is simply coefficient. And then the x is the independent variable, and then the u is the error margin I want to believe, if this is a regression model. So basically for cross-sectional, it has similar thing, but this time it's represented by the letter I below it. And then panel data, this is still how the regression coefficient looks like for it, but it has I and T. That's the cross-sectional and the time series aspect to it. So I'm sure those who are in the secondary, who are going to be using secondary data analysis, may identify with this. I don't work with secondary data often, so, but it was good to just bring this in. So you heard when we said about, when we mentioned independent variable here from this model. Can you see an X here and a Y in this model? X stands for independent variable. Y is for dependent variable. So Y is usually the outcome, like if you want to estimate something. So this is an estimation model, okay? If you want to estimate something, you're asking yourself, what will happen to a firm's performance if there are more employees, like if more employees have been hired, what will happen to the firm's performance? So if you have already successfully defined your model, you see that that X there is the employees. So if, let's say, 10 more employees are added, it means that X will change to 10, and then you put it in that equation. It will give you, when you put in the equation, it will give you a result for Y. That is the outcome, what will happen to the firm's performance. So X refers to independent variable. Now, what are the factors that determine the independent variable? Researchers don't just gather independent variables indiscriminately when you're modeling. So there are certain factors that determine a variable selection in modeling. Okay, so the independent variable here is simply that variable or that concept that you're using to predict an outcome. Some of the factors that affect the selection of an independent variable, number one is the theory. So if you have understood the theory you'll be using for your study, such theory can help you come up with a particular variable for your study. So I use an example of the solo growth model theory here, also known as the neoclassical growth theory. So this is an economic theory, okay? So neoclassical theory deals with output at macro level. And that theory states that there are three things that are responsible for economic growth. So if I'm carrying out a study, say I want to measure the economic growth of Nigeria, and then I'm looking for variables to use to measure the economic growth. I am hinging my study on the solo growth model. I would understand that the solo growth model states that there are three things that are responsible for economic growth. That is labor, capital, and technology. So those three things becomes my independent variable. Like that's what I can use now to measure. I can say, okay, my work is focusing on the effect of labor or the effect of capital on something or the effect of technology on something, because I am using, or my theory is the solo growth model. You can also come up with independent variables from empirical evidence, that is, variables that have been found to be significant in other studies. When you were doing your gap analysis as well, if you had focused on, so let's say if you had seen the work of other researchers that is related to your field, some persons may say this particular factor or this particular concept is not very significant when you want to measure something you intend to measure. Some might say this is significant, okay? So those variables that have been found to be significant over time can be used as your independent variable. And then finally, you can have just common sense, okay? So you want to see the effect of, so let's say you want to see the effect of child labor on, let's say, academic performance of the child. You want to see, let's say you're working on an economy that child labor is a problem, and you want to see how it affects the academic performance of the student. So child labor, you can ask yourself, how do you want to interpret, or how do you want to define child labor? Do you want it to be say paid employment, or just any kind of employment that the child undertakes, whether it's paid or unpaid? So those are the ways you can also determine your own variable too. So common sense can come in here as well. So we are talking about variable here because in statistics, or in statistics, especially when we get to inferential statistics, or when we get to inferential statistics and other kind of higher level statistics, you'll be hearing a lot of variables. So I hope I can really break this down. So independent variables are, okay, let me use an example right now. So my study is on aviation safety. My topic is on passengers' perception of aviation safety during COVID-19 and how it affects their decision to fly. So that decision to fly in marketing terms is called enplanement intention. So my topic is aviation safety and passengers enplanement intention. So it's like saying the effect of aviation safety on enplanement intention of passengers. Now, aviation safety is going to be my independent variable because it is the predictor. It is what is going to determine whether the passengers will fly or not. So passengers' intention to fly, or passengers' employment intention, is my dependent variable. if you want to look at it using common sense here, the intention to fly is not deep, is not the intention to fly does not cause the safety of the aviation or the airport. It is the airport safety that can rather influence the intention to fly. So the airport safety here is independent of any other thing. The safety is already there. Okay. Now, how does it affect employment intention? So you can see that it's employment intention that is depending on the aviation safety. That's why employment intention becomes my dependent variable, and the passengers, and the airport safety becomes the independent variable. So you need to identify, especially if you're working with quantitative study that has to do with a lot of relationship kind of thing or cost effect kind of thing, you need to understand the variable that you have. Is it independent variable? Is it dependent variable? You need to understand all of that. So we can then go on to discuss inferential statistics.